All right, today, chapter Algebra, lesson 5 is inequalities. The geometry is determine whether an equation or an inequality involving a variable is true or false for a given value of the variable. So we're going to need this sheet, half sheet of pink paper, and cut out the less than, the greater than, the less than or equal to, the greater than or equal to. We don't need the equal to because we are talking about inequalities, which are not equal. Yeah, that's my part's going to work. There we go. They're not equal. So, page 47 in our notebook, we're going to add these examples. X plus 4 is less than 15. So we're going to do this just like we've done everything else. We need to get that variable all by itself. So we're going to do the opposite of plus 4. We're going to subtract 4, which leaves us with x. So we need to do the same thing on this side. 15 minus 4 is 11. So our answer is x is less than 11. So x could be anything smaller than 11. What that means is we can fill in anything for x as long as it is under 11. So for a quick example, if we put 8, we put 8 plus 4 is less than 15. If we do that, we get 12 is less than 15. That is an accurate statement. Okay? Let's move on to the next one. The next one. Y minus 7 is greater than 10. So we're going to start again. We need to get our variable by itself. Opposite of minus 7 is plus 7. Cancels that out. I need to add 7. So y is greater than 17. So y has to be larger than 17. But it can be any number. It could be 18. It could be 44. It could be 102. It could be 1.3 million. As long as it is greater than 17, it will make that equation true. So now we have what's called less than or equal to. If you look over here, we have our less than sign, but we also have half an equal sign. So what this means is our number could be the same as the number because it's going to be equal to or less than. So we're going to do the opposite of 5 times x, which is to divide by 5, divide by 5. X cancels out, so x is going to be less than or equal to 125 divided by 5. Think of money in quarters. Is 25. So x can be anything smaller than 25, but it also could be 25 because it is equal to, it is less than or equal to. Now we're going to look at greater than or equal to. So here we have c divided by 6 is greater than or equal to 13. So we're going to take the opposite of divided by 6. We're going to multiply by 6. We end up with a c is greater than or equal to. Now we need to multiply 13 by 6. I get 18, carry the 1, so I get 78. C is greater than or less than 78. So C has to be anything larger than 78, but it could also be 78 as well. All right, so we're going to do some examples here. X plus 5 is less than 6. I have to subtract 5, leaves me with x. I have to subtract 5. So x has to be less than 1. X times 3 is greater than or equal to 9. Divide by 3, leave me with x. Divide by 3. Morning! And I get 3. X minus 2 is greater than 4. Opposite of minus 2 is plus 2. That cancels out x. I need to add 2, so I get 6. X is greater than 6. Now I have x divided by 9 is less than or equal to 1. The opposite of dividing by 9 is multiplying by 9. That cancels. I get x is less than or equal to 1 times 9 is 9. So I have 9 times x minus 3 is greater than 6. Now we have a two-step. So again, we're going to start on the side with our variable. We got to get rid of the first number first. So opposite is plus 3. That cancels out. So I have 9x is less than. So 6 plus 3 is 9. Well, I need to divide by 9. And divide by 9. That cancels out and gives me x. X is bigger than 1. So everything in this problem, any x you make would have to be greater than 1. So it could be 2, it could be 4, it could be 8, it could be 12, it could be 199. X divided by 4 plus 1 is greater than 10. So we're going to start with the number that doesn't have the variable on the left side. So we're going to subtract 1. Cancels that out. Leaves me with x divided by 4 greater than, well, I need to subtract 1 from here. So now I have to get rid of my 4. Opposite of dividing by 4 is multiplying by 4. X is greater than 9 times 4 is 36. So we know that x has to be bigger than 36. Okay. Now I have 3x plus 11 is less than 17. Again, we're going to come over here. We're going to start getting rid of this number. So we have 3x. Now we need to do the same over here. 17 take away 11 is 6. So 3x is less than or equal to 6. I have to divide by 3. I have to divide by 3. So I get my x on its own. So I have x is less than or equal to, where did that come from? Less than or equal to 2. So really what we're doing with this is we're just adding one more step to what we've already done with our algebra. Okay? So now, question number 1 says 10 plus x is greater than 17. 10 plus x is greater than 17. Okay, so I need to get rid of my 10. To get rid of plus 10, I'm going to subtract 10. Leaves me with x is greater than. If I take 10 away from 17, I get 7. X is greater than 7. Now, one of the ones that's a little tricky to understand. It says which inequalities could x be 3? Solve each inequality, then check the correct responses. So what we're going to try to do here is find where x could equal 3. So because we have greater than, or less than, or greater than, less than, or equal to, and greater than, or equal to, we got to be able to see if we can put the 3 in for that variable. So for example, 7x minus 3 is greater than or equal to 18. I'm going to add 3. I'm going to add 3. So I have 7x is greater than or equal to 21. Divide by 7. Divide by 7. I get 3. X is greater than or equal to 3. So if x equals 3, is 3 greater than or equal to 3? Yes, it is. So this then we're going to check. Now let's come down and look at one over here. 7x is less than 14. So to get rid of this, I'm going to divide by 7, and I'm going to divide by 7. So that cancels out, and I have x is less than 14 divided by 7 is 2. If I fill in my 3, is 3 less than 2? No. So that one would not work. I'm trying to find the ones where 3 would work. When you get down to 8, 9, and 10, it's 2 parts. So that is today. And sorry this is up late. The internet went down yesterday as I was posting this. So better late than never, I should say. Have a good day.